Well, hello there. This is Craig Hain. My students call me Dr. Dell. And this is going to be a review of trigonometry that is taught in the Practical Math Foundation course that you have already taken. And so this is designed to go along with the supplementary problems we've given you. And of course, I'm going to assume now that you've been through the trigonometry course, and this is strictly a review. So it's not a training video per se, but rather a review video of trigonometry. Now, as you'll recall, there are only 7 lessons that you studied for this trigonometry. That's all you need for practical math after the introduction. And then we had an optional 8th lesson, which we'll talk a little bit about. And so we're going to review these lessons now quickly so that you can then go and work on the supplemental problems that we've given you to go with them. Now, the first thing I'll remind you, in the introduction to trigonometry, trigonometry is essentially the study of triangles at the practical math level. And in fact, it begins with 3 basic trigonometry functions: sine, cosine, and tangent. And fortunately, today, there are several powerful power tools that are going to allow you to solve all the trig problems you need to do. Back in the old days, there were extensive trigonometry tables that were used. Sometimes they were included on a slide rule. Sometimes you had to look them up in books. And it was pretty arduous and time-consuming to use these. And today, all of these power tools are built into one calculator, the TI-30XA. Of course, there are other calculators, but this is the one we use because it's very, very useful. It's very easy to use. And of course, you've bought one. It only costs about $10. And here are the sine, cosine, and tan keys that you know we use for trig. And when you use the second key, you get the inverse sine, inverse cosine, and inverse tan. And of course, that's what we use then to do trigonometry. Now, in many ways, trigonometry is actually easier than geometry. You're going to learn to use these 3 trig functions to solve all types of geometry problems. And in particular, there are 2 very, very important tools or theorems that you will use. One is called the law of sines. That's lesson 6. And one is called the generalized Pythagorean theorem, which is more commonly called the law of cosines, but I prefer generalized Pythagorean theorem, and that's lesson T7. And then, as I'll tell you in the last lesson, there are many, many extensions of trigonometry into advanced mathematics that's used in STEM subjects, and we'll talk about that a little bit then in lesson 8. Now, you should recall that the first thing we did in lesson 1 was define the 3 trig functions we just talked about. And of course, it's defined like this. If you have a right triangle, and if you have an angle which we'll call x, then it has an opposite side and an adjacent side. We'll call that A for the opposite, and B we'll call adjacent. And then this straight line opposite the right angle is called the hypotenuse. We'll call that C. Then the definition of the trig functions are the sine of angle x is simply defined to be the ratio of A divided by C, or the length of the opposite side divided by the length of the hypotenuse. Now, the cosine of angle x is the ratio B divided by C, and the tangent of angle x is defined to be the A divided by B, or in other words, cosine is adjacent divided by hypotenuse. We're talking about the lengths there, and tangent is opposite over adjacent. Now, of course, it then turns out you can easily demonstrate then that the tangent of x is the same as the sine of x divided by the cosine of x. And these then are the definitions of the 3 trig functions that you learn. And because we have a wonderful tool to do it with, you can also then define the inverse functions. And all you do there, for example, if sine of angle x equals A over C, then we say that angle x is equal to inverse sine of A over C. If you apply the inverse side to both sides of this equation, you get inverse sine of A over C on the right. And then when you take the inverse sine of the sine, they cancel each other. That's what inverse functions do, and you get angle x. And so these then are the definitions of the 3 inverse functions for sine, cosine, and tangent. And those are the definitions that we teach you in lesson 1, and we give you a lot of problems to do then, where we give you specific values of A, B, and C, or specific angles, and we have you calculate the sine of those different angles. Now, in the next 3 lessons, 2, 3, and 4, we teach you how to use these trig functions to solve triangle problems that you can't do with just ordinary geometry. That's why you need trigonometry. So let's take this triangle here. It's a right triangle. It's a 90-degree angle. This angle is 23.6 degrees. This side is 7.8, this side is 3.4, and this side is 8.5. Now, if you know two of these, then you can always calculate the remaining ones. For example, if you just knew these two sides here, you could use the Pythagorean Theorem to get this. But suppose you knew, you just knew the hypotenuse and you knew this angle. Well, then you would need trigonometry to calculate the 3.4, and in turn the Pythagorean Theorem would give you this, or the cosine would give you this. Now, what you need to do, and what we did in the problems, and you'll be doing in these supplementary problems, is you're just going to do a lot of these calculations. So, for example, in this particular example, the sine of 23.6 degrees, if you plug it into your calculator, you get 0.400, but that's the same as taking 3.4 and dividing by 8.5. Do that with your calculator too, and that verifies, of course, that these are equal, which you knew they were. That's the definition of sine. Now, another way you can look at this is that this angle, 23.6 degrees, is the inverse sine of 3.4 over 8.5, which is 0.400. And so that's another way to look at it. These are basically, this equation and this equation are essentially equivalent, don't you see? You just take the inverse sine of 0.400, and that'll equal the inverse sine of the sine of 23.6, and that'll give you that. So you can go either way. Now, the way we often do problems is we'll say, all right, suppose you know this angle, and suppose you know 8.5, and this is a right triangle. What is x? Well, you know that x divided by 8.5, by definition, is the sine of this angle, which you know, and you plug it in your calculator, and you get 23.6 degrees. Take the sine, you get 0.400. Now you got a little algebra to do. X now is equal to 0.400 times 8.5, which is 3.4. So then you can figure that out. So if you know any two of these things, you can use the trig functions to find the others. And of course, once you know this angle, you know this one. And if you knew, for example, if you knew that if you wanted to know this, down here you would use the cosine. If you knew the hypotenuse and the angle and you didn't know this, you use a cosine instead of the sine. There's lots of ways to solve these problems, and we give you tons and tons of problems like this to do. And that's what you're going to do with these supplementary problems, and then you really understand the trig functions and how to use them to solve triangles. Now remember that the Practical Math Foundation is designed to teach you all you need to know about trig to do practical problems. Well, it turns out that often you use the inverse sine to solve problems, and here's a warning that you need to know. Suppose you have two supplementary angles, angle 1 and angle 2. That means they add up to 180 degrees. And we'll represent them in this triangle like this. Here's angle 1, it's less than 90, and this is the side A, this is a right angle. And then its supplementary angle is angle 2, and this is the side C, the hypotenuse opposite this right angle. Well, it turns out now that, as you know, the sine of angle 1 is defined to be A divided by C. Well, it also turns out that's the definition of the sine of angle 2, which is greater than 90 degrees. Now, this is something that you can verify with your calculator. Now the question becomes, suppose you knew A over C, and you wanted to know what angle it came from. Well, you take the inverse sine of A over C. The question is, are you going to get angle 1 or are you going to get angle 2? And the answer is you're always going to get angle 1, which is less than 90 degrees. You're not going to get angle 2. But you might be working a problem where you want the angle that's greater than 90. So all you have to do when you take the inverse sine then and get angle 1 is you just subtract that from 180 and you'll get angle 2. But you have to understand that. And we discussed that extensively with lots of problems in lesson 5. And you'll need to understand that for sure to be sure you don't make a mistake that sometimes people make. Okay, now in the next lesson on the law of sines, here's an interesting situation. You've got a triangle and you know all of these three angles, 1, 2, and 3. These are known, and you know the length of a side A. And you want to know the length of this side x. How are you going to find it? This is not a right triangle, so you can't apply the sines and cosines directly because this is not a right triangle. This applies to any triangle. Well, what we did back in geometry, if we could find a similar triangle, that's a triangle probably of a different side, but it had the same angles, 1, 2, and 3, same values. And if you knew two of those sides, you could set up a ratio. You could say that x divided by A is the same as C divided by B. You have to use corresponding sides, then you get a little algebra and you can solve for x. And this is very useful. In fact, I told you this was the most important tool in geometry and very useful and often used. But suppose you didn't have this similar triangle. And now what are you going to do? But suppose you do have trigonometry and this wonderful tool. Well, there's something called the law of sines that's going to let you solve this. And it works like this. If you take x and divide it by the sine of the angle opposite, which will be sine of angle 1, that'll be equal to a divided by the sine of the angle opposite it, angle 2. So now you've got an equation involving 3 known and 1 unknown. So x is going to be a times the sine of angle 1 divided by the sine of angle 2. That's called the law of sines. It's extremely useful. You can't do it unless you've got no trigonometry and can use trigonometry. But when you've got trigonometry and you've got a nice calculator like this to use, this becomes very, very easy. And in fact, then it's even many times easier than using similar triangles. Just depends on the tools that you've got. And so we teach that in the law of sines. And now the last lesson we teach you in the practical trigonometry, is what I call the generalized Pythagorean theorem. And let's start out and review the Pythagorean theorem. You've got a right triangle. This is a 90-degree angle. 3 sides, A, B, and C. C is the hypotenuse. And the Pythagorean theorem, we know, says A squared plus B squared equals C squared. This is something we learned very early in geometry. This is something the Greeks discovered. And, of course, it's extremely useful whenever you have a right triangle. But then the question becomes, what happens if you don't have a right triangle? Suppose you've got a triangle, again, A, B, and C, but this angle 2 here is not a 90-degree angle. Now what do? Well, basically you would be stuck if you're just dealing strictly with geometry. It would be very difficult, but look at this formula. C squared is equal to A squared plus B squared. So far that just looks like the Pythagorean theorem. And it would be if angle 2 was a 90-degree angle, but it's not. So what we have to do is we have to put in a correction factor. And that correction factor is minus 2, nothing to do with angle 2 now. It's minus 2 times A times B times the cosine of angle 2. So if this angle right here, say, was 39 degrees, this would be the cosine of 39 degrees. And this is what I call the generalized Pythagorean theorem. Now, it is called normally the law of cosines because this is a cosine. And so that's a name it's been given historically, and of course we have to use that. I think of it as a generalized Pythagorean theorem because it's really the Pythagorean theorem with a correction factor when this angle is not 90 degrees. And as a matter of fact, if angle 2 was 90 degrees, we know that the cosine of 90 degrees is 0, and so this correction factor is just 0. So this is always true no matter what angle 2 is. And then this is the last lesson that we have in the practical math for trigonometry. So don't you see how easy trigonometry really is, and all you need to do is a lot of problems. Now in lesson number 8, I talk about trigonometry beyond practical math. You learned everything you need to know for practical math. But if you're going to go on into science and technology, into STEM subjects, you're going to learn that trig is a really, really important subject, very extensive subject. In fact, the trig functions are defined by circles. Then you extend the definition to any angle, positive or negative. You'll find out they're very important in calculus, but they're extremely important when you learn the complex number system, which you'll learn in Tier 4 in our program. And this, of course, is extremely important in quantum theory and electronics and so forth. I can't emphasize how important it is. They're also used in something called Fourier transforms, which is the way you analyze modern signals in spectrum analysis. And of course, you'll learn all about them by studying their graphs and analytical geometry. Now that completes the review of trigonometry. And as you know, it was just a very small section of the whole practical math course. You had all of the geometry, you had the 19 lessons of geometry, you had algebra, you had pre-algebra, and you had calculator. And as a matter of fact, when you learn all of these subjects now that are in this practical math foundation, you'll be able now to do any kind of problem that's going to likely come up in industry in a non-professional technical field. And there's hundreds of those. So you're now well prepared to go off and learn all sorts of things that'll be of great value to you and hopefully help you get a good job and pursue a great career. Now, of course, you can go to my website at craighane.com, and there's a lot of materials there where I discuss all of these things in great detail. However, I would like to invite you to also go to triadmathinc.com, where there's even more free material, all sorts of things where you can learn how our program works and how you can learn to win with math, how you can learn math quick and easy and fun using the triad of effective math education. And so this is Dr. Dell inviting you to learn mathematics and then have a wonderful future.